Well, good afternoon. What do a map of Australia depicting drought, a picture of a building of the University of Queensland, and an egg timer have to do with the 3-minute thesis or 3MT competition? In the mid-2000s, Australia suffered a historic drought as shown in this figure on the left-hand side. Citizens were asked to conserve water, and the citizens of Brisbane resorted to very creative methods. The then dean of the graduate school at the University of Queensland in Brisbane used an egg timer as shown here while taking his shower. In pondering as to what else could be done in 3 minutes or less, conceptualized the idea of the 3-minute thesis competition. Needless to state, the first 3MT competition was hosted by the University of Queensland in 2008. Since then, the competition has spread to over 900 universities worldwide and across 85 countries. Today, we have the privilege and honor of hosting our second 3MT competition, the first in-person competition. The 3MT competition provides an opportunity for graduate students to communicate their key research findings in one PowerPoint slide and within 3 minutes, and also narrate their research such that a lay audience can understand. Thus, this competition helps graduate students to hone their communication skills. In addition, it is a great opportunity for graduate programs to showcase the rich diversity and quality of research and creative scholarship in their programs. For administrators like us, it is a great opportunity to engage with the public and the legislators and showcase the high quality of research and creative scholarship across the various colleges and advocate for increased support for post-secondary education. Thank you. This, by the way, was a 3MT style presentation using one PowerPoint and within 3 minutes. So just as some ground housekeeping rules, if you could check if your phones are muted, it would be very helpful. We do not want the contestants to be distracted. And these are the competition rules, just as FYI for all of you. We have 3 judges, Ms. Alicia Pennington from CITO, Ms. Amy Bingham, and Dr. Anthony McAdoo from Philanthropy and Alumni Engagement. All staff roles and their feedback and rankings will be helpful for us to come to an informed decision. The winner of this competition will represent WKU at the Midwestern Association of Graduate Schools annual meeting 3MT competition in Milwaukee, and I happen to be the chair of the association. We have 4 contestants today, and they will go in alphabetical order. And our first contestant is Ms. Whitney Hurd, who will talk about her research related to antibiotic resistance. Ms. Whitney?
At some point in your life, you've probably taken an antibiotic to treat a bacterial infection. And more times than not, it's probably cleared that infection. But what happens when there comes a time when that doesn't work? Usually you'd want to try something new. An alternative could be natural parasites that attack bacteria. These natural parasites are called bacteriophages, and out in the world, these guys are everywhere. With the emergence of multi-drug resistant bacterial strains, such as that purple guy on the far left, bacteriophages could provide a new and alternative treatment option to antibiotics. So, the focus of my research has been the functional characterization of a particular mycobacterium phage called moo-moo. What makes moo-moo special is that it is a singleton bacteriophage. And what I mean by that is that its genome doesn't really match anything well enough for it to be classified into a phage family. That can seem pretty lonely, but it also makes it the talk of the town because with this uniqueness comes a lot of unknown gene function. And it has been my job to try and figure out if any of those genes have toxic effects. And it turns out that they do. Now, hear the word toxic, you would think of something bad. But what if toxicity could be used for good? How could we use genes to our benefit in terms of treating bacterial infections? First, you have to know what they do. And to do this, I'm using an interaction assay, which is essentially a test used to determine the target of a toxic phage protein. This toxic phage protein is made from the gene by the host cell, which also makes a lot of host proteins called a library. When I say host, I'm referring to Mycobacterium smegmatis. This bacteria is not particularly harmful to humans. However, it is related to the much more pathogenic bacteria, Mycobacterium tuberculosis. So essentially, I am using a simpler and safer model to work with. Oh, sorry. Now, back to the assay. If you look at the figure, when my sorry. Okay. I have a loud mouth. I can talk loud. So, when my toxic phage protein interacts with a particular host protein, this interaction causes a bacterial colony to turn blue. This blue color is then interpreted as a signal such that strong interactions are dark blue, weak interactions are light blue, and then if there's no interaction at all, the bacterial colony will stay white. And it's through screening and selection dependent on those interactions that I will choose bacterial colonies with a strong signal to be sequenced and characterized. And then from there, hopefully a mechanism can be proposed for the function of this gene, but more importantly, aid in identifying new drug targets which ultimately can cause dead bacteria, like this guy on the right. Thank you.
Well, thank you very much, Whitney. Whitney is a research mentor as Dr. Rodney King, so I'd like to acknowledge his contributions as well. Our second speaker is Ms. Amy Horrigan from the Master of Science in Biosciences. Amy?
Climate change involves several complex components that make it seem impossible to address.
Y'all get my changing the slide for us.
Why don't you start now? We can some apologies. Start now.
Start now. Climate change involves several complex components that make it seem impossible to address. Research in understudied subjects like carbon cycling in the karst groundwater system can contribute to research to reduce the impacts of climate change. We know that CO2 or carbon dioxide is directly related to rising global temperatures. Carbon moves throughout a karst groundwater system through the entire critical zone, which includes from the atmosphere to the surface and the subsurface. Rock has an extremely large ability to store carbon and remove it from the atmosphere because it has so much carbon in many types of rock. About 20% of the Earth's land is made up of karst landscapes, and those are formed in carbonate rock like limestone. These landscapes are unique because this is where you can find caves, sinkholes, and underground river systems. This illustration shows carbon cycling through the entire critical zone, and you can see carbon being dissolved by water in the atmosphere and the soil to create a weak acid that dissolves limestone. Now, throughout the karst groundwater system, other processes are constantly occurring which put out or remove carbon from the system. When the underground river emerges from a stream on the surface, the water holds evidence to whether this system is a carbon sink or not. Since the 1980s, researchers have tried to understand a discrepancy between total carbon emissions and carbon concentrations in the atmosphere. This is known as the missing sink. My research research tests the theory that an urban karst groundwater system could be a carbon sink by sampling Lost River Cave in Bowling Green, Kentucky. At the end of my research, I'll have 9 months of data to analyze and report, and preliminary results suggest that Lost River Cave does remove carbon from the atmosphere, and considering the global distribution of 20% of the land being karst landscapes, this could account for tens to thousands of tons of carbon dioxide being removed from the atmosphere. This could account for part of the missing sink. My research will also give insights to urbanization's impacts on karst.
Thank you, Amy. Amy's research mentor is Dr. Jason Kirk, and I'd like to acknowledge his contributions. Our third presenter is Salazar Kulbach, who is from the Physics and Astronomy program.
Without microphone. Back in 2012, I was in Kyrgyzstan, which is my home country in Central Asia. And one of my arts and humanities teachers got a hip replacement surgery. But unfortunately, she had 4 months of unending complications, which ultimately led to a secondary treatment and costed her an extra $20,000 and a lot of nerves. And interestingly, the metal corrosion problem, which was the main culprit of those complications, is still unresolved until these days. The main issue here is, since human body is acidic, it dissolves the metal surface, and toxic metal ions get released from the implant. And based on official reports, of overall 900,000 cases of hip and joint replacement surgeries performed in US alone in 2020, 45,000 cases fell into this stage, which is a huge number. And in our lab, we are trying to propose a solution for this problem. And guess what? The results were more than what we expected. Let's think about it. So usually, especially in engineering design, nature inspires us to prototypical ideas. And we also thought, can we resemble the metal device to human bones? And can you guess what is the simplest way of achieving that? Any from the audience? Okay, the simplest way is shown here. We can coat the metal surface with calcium phosphates, which are inorganic ceramic materials existing within human body. So we utilize lasers to deposit calcium phosphates from the source to the metal implant, and we obtain micrometer thick calcium phosphates, which exhibited billions of times of lower dissolution rate at acidic environment, which ultimately proved our idea. In addition, it's a versatile and cost-effective idea. So you can apply with a minimal budget the system to any implants with various range, except there are one implant category that you cannot apply, and that implant is metal on metal implant because they should be in contact and you cannot coat them. But except that, everything can be done. And based on our estimations, the frequency of this problem can be dropped from 5% to and 0.5% finally. And now in hindsight, looking back in 2012, I can happily say that we are most likely a step away from resolving this problem industrially. And I'm truly glad and I'm truly excited to be part of this process, and stay healthy, and thank you so much.
Simone Whalen is our fourth contestant, and we'll talk about LCMS studies for determination of data differences in low iron level.
largest economic impact to the dairy industry? Well, it's not cow tipping, it's mastitis. Mastitis is a sudden onset of inflammation and swelling of the udder, resulting in a clogged milk duct. This costs the dairy industry an average of $2 billion a year. A healing protein, beta-deficins, could be used to treat, cure, and even prevent mastitis. These beta-deficins are secreted in cow's milk when healthy, but secretion increases when mastitis is present to naturally cure the infection. Beta-deficins have been analyzed in cow's blood, but none of their milk, where their secretion occurs. Being able to understand the beta-deficins' natural defense to the mastitis will allow future researchers to implement new treatments for mastitis. Currently, the only treatment available is antibiotics. This has resulted in overuse and antibiotic resistance in cows. It has also raised concerns about antibiotic residues passing through dairy products and contributing to antibiotic resistance in humans. So, by analyzing hundreds of samples of milk, I was able to develop a method that got out fats, lipids, and whey proteins out of the milk by keeping the beta-deficins behind. This cleaned milk could then be injected into this instrument, a liquid chromatography mass spectrometer. Then, by deliberately varying parameters on the instrument, like temperature, I was able to obtain data that clearly showed the protein desired, as seen here. By developing this method and partnering with the USDA, the hope is that a better treatment for beta-deficins for mastitis could be developed. By fundamentally understanding the innate defense of beta-deficins, future researchers like the USDA will be able to understand the concentrations of beta-deficins needed to treat the mastitis. Instead of injecting antibiotics, they could inject beta-deficins, increasing the cow's beta-deficin concentration, resulting in a natural defense of the mastitis. Beta-deficins are the perfect replacement because it's the cow's innate defense, they are not harmful to humans, and can result in better dairy products. So remember to drink your milk, but don't go tipping any cows.